So today we're going to start learning about the process of factoring. So up until now with our polynomials, what we have been doing is we've been doing our arithmetic. So polynomials, we've been combining them. Or the other term we use is simplifying. So we've been taking them, getting them together, simplifying them down so they're in the simplified form is really the word for it. So what we're going to start doing is we're going to start practicing the skill of factoring, which what that does is it helps us break those polynomials apart so that we can work on figuring out a solution to them when they're in an equation. We can't figure out a solution with the way that they are, so we break them down by factoring them so that we can figure out that solution. So factoring means that we're finding factors, which are expressions that multiply together to give the original expression. So we're breaking it apart, so almost kind of like division, so that we can figure out the two expressions that end up getting multiplied together to give you where we started. So for example, 2x and 3x. If I multiply those together using our rules that we've been factoring, 2 times 3 gives me 6. X times x would be x squared. So 2x and 3x are the factors of 6x squared. So we're going to use the first factoring method, which is the greatest common factor, which is a lot of times just shortened down to be the GCF. So the greatest common factor is the largest number that divides evenly into the original numbers. So for example, the GCF of 12 and 16, what you're trying to do is find the largest number that goes into both. So one option you have is to write out all of the factors. So for 12, 1 times 12, 2 times 6, 3 times 4. 16 would be 1 times 16, 2 times 8, and then 4 times 4. So the largest factor that they all both have in common would be that 4. So the GCF of 12 and 16 is 4. So the GCF of monomials, and remember monomials means that it is one term, so the GCF of our monomials, the way we do that is you find the GCF of the coefficients, kind of like what we were just doing with the 12 and the 16. You're trying to find that largest number that goes into both of those, and then any common variables with the smallest exponent. So you largest number, but yet the smallest exponent is what we're using. So if we look at this example here, looking at 15x cubed, looking at 20x to the fifth. So if we start thinking about the factors of 15 and 20, the largest one is going to be 5 that goes into both of those. And then again, your smallest exponent. So our GCF of those two terms would be 5x to the third. So the factoring by using your GCF method. These are the steps that you will follow. Step 1, find the GCF of all of the terms. So if I look at my two terms here, I have 6x squared, 18x to the fifth. Got to find the largest number. So between 6 and 18, that's going to be 6. I always like to try whatever that smallest coefficient is, see if that goes into the other one, because a lot of times that works out. In this case, it does. 6 does go into 18, so that's going to be my largest number. And then again, it's the smallest exponent, so it's going to be x squared. Your second step is to divide the terms by the GCF. So 6x squared plus 18x to the fifth. I'm going to divide them both by my GCF that I just found, which was 6x squared. So 6 divided by 6 gives me 1. Those x's will cancel since they're the same exponent. 18 divided by 6 gives me 3. 5 minus 2 gives me x to the third. So when I divide by my GCF, I get the binomial 1 plus 3x to the third. Step 3 is the way that we write our answer, and that's your GCF gets written outside of a set of parentheses with the stuff that you just got from multiplying inside the parentheses. And you can check your answer, and it's always recommended that you do check your answer by distributing. So 6x squared times 1 would give me 6x squared. 6x squared times 3x to the third gives me 18x to the fifth. So it checks out because it matches exactly where it was that we started. So this with the GCF on the outside, the other stuff inside the parentheses, that is our answer. So what we did is we took our expression, the 6x squared plus 18x to the fifth, and we just broke it apart. And this is, again, going to help us later when we're going to try to solve equations. So we're just practicing a skill for now. So looking at our examples, we're going to start going through some examples here. 15 and 25, the largest number that goes into both of those would be 5. Looking at my y's, y squared is my smallest exponent. So again, if you remember, we're going to divide both of these by 5y squared. 15 divided by 5 is 3. 3 minus 2 is 1, so I get y to the first. 25 divided by 5 gives me 5, and then these y's will cancel because they are the same exponent. So that is my final answer there. Next one, even though it is 3 terms, it's going to be the same process. So we got 9, 3, 27. My largest number that goes into all of those would be 3. X cubed, x squared, x to the first. So that x to the first is going to be my GCF. And then I'm going to divide each of these by that GCF of 3x. 9 divided by 3 is 3. Subtract those exponents like we were just practicing with our division rules a couple days ago. So I get 3x squared. 3 divided by 3 is 1. 2 minus 1 gives me x to the first. Plus 27 divided by 3 gives me 9, and then those x's would cancel because they're the same exponent. Next two examples on here. 7 and 49, GCF would be 7. X to the first, x squared, so I would use x to the first. Y squared, y to the first, so I would use y to the first. And so I'm going to divide both of those by 7xy, because that was our GCF. So 7 divided by 7 is 1. X's would cancel. 2 minus 1 makes that y to the first. Plus 49 divided by 7 is 7. 2 minus 1 makes x to the first. My y's are going to cancel. Remember, these coefficients of 1s, you don't have to write them, but it's a good habit to get into, because whenever your GCF is the same as that term, like it was up here in our first example, that 1 has to be there. It can't just disappear, and it's not just going to be 3x to the third, because then when you try to distribute again later, you're not going to get the same answer. All right, example for this trinomial here. We got 12, 36, 18. When I first look at the 12 and the 36, I think, okay, 12, but 12 doesn't go into 18, so there goes that idea. So 12, 36, 18, my GCF for the numbers would be a 6. And then if you look at these, the first two terms have an x, but the third term does not. So x is not going to be part of my GCF. And then with the y's, again, 2 of the terms have y's, but the first term does not. So y also is not going to be part of my GCF. My GCF is only going to be that 6. 12 divided by 6 is 2. 36 divided by 6 is 6, and those exponents are going to stay the same. 18 divided by 6 gives me a minus 3. So I know the hard part might be figuring out that number. That's why I gave you that multiplication chart in the front of the packet. You can always look there to try to figure out your factors. take a look at some more examples on here. So between 2 and 6, I would have 2 x to the first. So that's going to give me 3x squared plus 1. Again, when you divide here, 2 divided by 2 is 1. That 1 has to be there, but when an x stays or a y stays, we don't always write the 1, but it is still there, and you do need to still write that. All right, next one, 25 and 45, so that's going to be 5x to the 5th. So 5 plus 9x. You do not always need to show that division. You can do it in your head, just like I did for that second example right there, or keep writing it if you need to. I'm going to kind of do it both ways, but again, you don't have to keep writing it. 12 and 18, that's going to be 6, and then y to the first, 2y cubed plus 3, 4, 4x, then it's going to be 5x squared, 4x minus 1, because again, at any point in time, you can pause the video, try these on your own, and then hit play to see if you got them right. That's a really good thing to be doing if you're watching the video. 18 and 27. 9, y to the first. So that would be 2 minus 3y squared. Six and 9 would be 9, x to the first, y to the first. Again, we divide to be able to get what's left inside the parentheses. And we divide because our way of checking would be to distribute, which would be multiplication. 14, 49, 28. So those would be multiples of 7, and then x, so that's going to be 2x squared minus 7x plus 4. 10, 5, 25, 5. X to the first, y to the first. Again, always make sure each term actually has all of those letters. There's a problem with this one. This one's not actually my final answer. Does anybody notice what happened? I have some like terms in here, so I got to combine those. So 5xy and then x squared plus 5y. That would be our final answer. You always got to combine your like terms. I missed them up here. And you know, like terms need to be combined. We'll have to look out for that. Number 9, 24 and 5. Well, the only thing that can go into 5 is 1 and 5, but 5 doesn't go into 24. 24 is 1 and 24, 2 and 12, 3 and 8, 6 and 4. So this one is what we call prime. Can't be factored. That happens sometimes, but it doesn't happen all that often. So if you get stuck on your homework, that doesn't necessarily mean it's a prime polynomial. 10, 2y would be our GCF, so that's y to the third, minus 6y squared, plus 3. This would be negative 3xy. So it's going to be 1 plus 3x. If that first term is negative, your GCF is also going to be negative. So same thing here in number 12. Negative 5x1y1. So remember, you are dividing So the next page in your packet, it says factoring using GCF practice 2. Try that one on your own and then reach out to me to see if you have any questions and to check to see if your answers are right. So that practice page number 2 is what you're going to be working on next.